Welcome. What we're going to do right now is go through the Identifying Reaction Types Part 2 video in this reaction types series. What we'll do in this video is we're going to analyze single displacement, double displacement, and acid-base, or also known as neutralization reactions. Now, to do that, let's first take a look at single displacement reactions. So, in a single displacement reaction, the general form will take the shape of A plus BX yielding AX plus B. Now, the displacement that occurs here is A is going to come in and displace B. B is going to get kicked out and B alone by itself. So that's the displacement that occurs. Since A goes into that compound, you end up with AX rather than BX. Now, in a single displacement reaction, only similar elements will displace similar elements. This general form is suggesting that A and B must be similar, but X must be dissimilar. Now, what does that mean with respect to elements on the periodic table? Similar elements are on the same side of the stair step. So A and B are likely both metals. Actually, they are both metals because B was written first and metals are always written first. So both elements would be on this side, whereas X would be somewhere on the right. X would be classified as a nonmetal on the periodic table. One thing that you always need to make sure you do when investigating single displacement reactions is check an activity series. Okay? It's also sometimes called a reactivity series. And basically what activity series do, or reactivity series do, is they rank the metals, and they make these from nonmetals as well. They rank them based on their activity or reactivity, where elements at the top of the list are more reactive, and elements at the bottom of the list are going to be less reactive. Now what this means is if we were to take two elements, let's say aluminum and copper, and if aluminum were by itself and copper were in a compound, okay, so here's aluminum, and if we look around for copper, of course, it's all the way down here. So you can see that aluminum is much, much more reactive and much more active than copper. Since aluminum is more reactive, if it is placed in a solution where copper is in some sort of compound, like copper 2 chloride, then aluminum will displace copper. But if aluminum was placed in a solution that contained something like barium, then no reaction would occur because aluminum is not more reactive than barium. So barium will remain in the compound and aluminum won't be able to react with it because it is not classified as being more reactive or more active. So an activity series is very, very useful. You can Google one or use whatever search engine you like and find a reactivity series. That's going to be extremely helpful to determine whether reactions actually happen or not. And those are applicable with single displacement reactions. Now the next type of reaction that we're going to look at instead of single displacement are double displacement reactions. In a double displacement reaction, the same concept is going to take place. The same idea is going to take place, where you have AX combining with BY to form AY and BX. The only thing in this case, as the name suggests, there will be two displacements occurring. A will displace B, and at the exact same time, B will displace A. So you have two displacements taking place. Instead of AX, you have AY. Instead of BY, you have BX. You have two brand new compounds. Again, similarly, as in single displacement reactions, similar elements will displace one another. A and B are both going to be metals, and so those two are going to displace each other. A will not displace Y because two metals don't form an ionic compound, and so that's just not going to happen for you in a chemical reaction. Excuse me. One thing, the trick for using double displacement reactions, a lot of times one of these two products, one of these two products, a lot of times is going to end up turning into a solid. So these two could both be in solution. You could mix them, and one of these could turn into a solid. And what you need to determine which one might turn into a solid is a solubility table, or a set of solubility rules. And these rules, sometimes you need to memorize them, sometimes you'll need to memorize a few of them, but you should always be able to locate them. All right, so you should find and download a table of solubility rules, so you know what kind of solids would be made during a double displacement reaction. All right, and that's the last main idea, is make sure you check those solubility rules so you know which kind of solids are going to be formed during your reactions. Now, the third type of reaction that we want to investigate in this video are acid-base reactions, or also known as neutralization reactions. Again, depending on the resource, you might see it written one way or another. Right here today, in this video, we're going to take a real light gloss coating of these reactions. Many chemistry courses will dedicate significant amount of time strictly to acid-base reactions. And you'll learn about all different types of acid-base reactions. But here's a general type where you have HA, where this is hydrogen and this is some nonmetal, plus some metal B and hydroxide OH, to form BA, because B is the metal and A is the nonmetal. Metals are always written first. Forms BA and water, where this is classified as a salt. So this salt that exists as a product is actually the form BA. Now, many students and many people in general think that salt is strictly sodium chloride, so that it's strictly NaCl. And that is accurate. Salt is NaCl, but it also could be MgCl2. It could be take on many different shapes. It does not need to have chlorine. It does not need to have sodium in it. It just needs to be an ionic compound. And then the other product, of course, is water. Now, this is a pretty strict reaction because you have to have a leading hydrogen and you have to have a following hydroxide as a reactant. And in that, you will always form some sort of salt and you will always form water. So acid-base / neutralization reactions are relatively simple and straightforward to identify the reaction type of. So without further ado, let's go ahead and see if we can identify a few reaction types. And here's my list of examples for you in this video. And let's take a look at this first one. Well, this first reaction contains, you have aluminum plus CuCl2, that would be copper 2 chloride, forming aluminum chloride and copper. Well, if you recall, in a single displacement reaction, what happened? A went into B and kicked B out. But what we should always do is check the activity series to make sure this first element that's all by itself that goes into the compound is more active. Because if it's not more active, then there would be no reaction, and you should write the answer, no reaction. So let's check our activity series. And when we look at our activity series, if you remember when I went through, the first example that I gave you was aluminum and copper. And we already saw that aluminum is way more active than copper. So this reaction will definitely happen. Aluminum will definitely replace copper in this chemical reaction. And so this is a single displacement reaction. All right. Eventually we'll practice balancing, and you can balance that equation. That's something that you should definitely always be doing, whether you're asked to or not, from here on out. Next, let's look at this reaction. HCl plus KOH yields H2O plus KCl. Now, when I look at that, initially I think double displacement. Because in a double displacement reaction, I've got two compounds forming two compounds. And that's one of the dead giveaways for double displacement, or one of the big hey, this might be double displacement. It kind of looks like it. However, if you can recall the acid-base reaction, acid-base reactions are pretty strict. We have a leading hydrogen followed by a non-metal, and then a metal followed by a hydroxide, OH is hydroxide, forming Ba, that's your potassium chloride in this case, and water. Now, recall, 7 plus 8 equals 8 plus 7. So just because the salt is written first in the actual general form that I gave you here, it doesn't matter that it's written first here, okay? Or I said that backwards. Since the salt is written first here, it doesn't matter that it's written second up here, because 7 plus 8 is the same as 8 plus 7. So in this reaction, this would be our acid-base reaction, also known as neutralization. Now let's look at this final one. This final chemical reaction, we have lead 2 nitrate combining with potassium iodide, forming lead 2 iodide and potassium nitrate. And here we definitely have a double displacement reaction. You can tell it does not take that form of that acid-base reaction, but let's try to annotate this or show you the displacements that are taking place, just to make sure we're perfectly clear. So lead ought to come in and kick out potassium, and potassium ought to come in here and combine with the nitrates. See if that happens. See if we got Pb and I. We sure do. And see if we have K and NO3, and we sure do. We have K and NO3. The last thing that we'll do real quick is make sure that Pb and K are quote-unquote similar elements. Well, lead is located right here to the left of the stair step, so it's classified as a metal, and potassium's way over here. Okay, lead and potassium are both metals, so those are the displacements that happen. If we wanted to, we could check the solubility rules and figure out which one of these two products is a precipitate. Okay, and there is one. All right, this one is will precipitate out. All right. And you ought to check a solubility table to verify that. All right, so what we've done in this video is we've identified reaction types. We've taken a look at single displacement, double displacement, and acid-base reactions. Now you should be good and ready to roll for identifying different reaction types. The next step would be to predict the products in a reaction. And that's why it's going to be essential for you to be able to identify reaction types, because that's going to be the first tool in your tool bag to figure out what kind of products will be formed during a chemical reaction. So that's all for now. Hopefully this helps you out and gets you where you need to go. Thank you.